The distributive property. Let's look at an area model where we have to write an expression for the area of a rectangle whose width is 4 and whose length is x plus 2. So think about your prior knowledge of area and how you would find the area of specifically a rectangle and how this could relate to the distributive property. Well, we can think of this rectangle as actually being two different rectangles. We have this green rectangle and this yellow rectangle. The green rectangle has an area of 4 times x, or 4x, because the area of a rectangle is the length times width, and there's a length and a width of 4 and x. The other rectangle that's yellow would have an area of 4 times 2, because we can carry over this width of 4 for the yellow rectangle. It's the same as the green rectangle, but now there's a width of 2. So then the expression for the total area would be to add up the area for the two small rectangles together, the green and the yellow. So 4x, or 4 times x, plus 4 times 2 is going to give us an area for that total rectangle of 4x plus 8. But instead of thinking of this rectangle as two different rectangles, as a green rectangle and a yellow rectangle, we can also think of this as one large rectangle where we would have a width of 4 and a length of this entire side being the expression of x plus 2. So that area would be, length times width would be 4 times x plus 2. But here we have an expression for the total area as 4x plus 8 from finding the area of the two smaller rectangles. And we have this expression of 4 times the quantity of x plus 2 from the area of the larger rectangle, which is the same. So that means these two expressions are going to be equal. Finding the area of each rectangle first demonstrates the distributive property. So here we had the area for the entire large rectangle as 4 times the quantity of x plus 2. But when we break down each product, when we look at just 4 times x plus 4 times 2, we end up with 4x plus 8, which was our area when we were finding the two smaller rectangles. The 4 is distributed to each of the sum of x plus 2. The 4 is multiplied by each term of the sum x plus 2. And that's the distributive property. So let's try some before we look at our formal definition of all the possibilities. So here we have 6 times the quantity of x plus 4 and 5 times the quantity of x plus 7. So the distributive property tells us to take that number on the outside of the parentheses and to distribute it to the sum inside the parentheses, to distribute it or multiply it to every term inside the parentheses. So we'll be doing 6 times x and 6 times 4 for the first expression, which will lead us with 6x plus 24. The second problem we have, we'll do 5 times x, that's the first product, and then plus 5 times 7 for the second product, which simplifies to 5x plus 35. Checking our answers, we do get that 6 times the quantity of x plus 4 is equal to 6x plus 24, and 5 times the quantity of x plus 7 is equal to 5x plus 35. Here are 2 more problems. It says write an expression equivalent to 2 times the quantity of x minus 1 and 4 times the quantity of x minus 8. So here we're using the distributive property because we still have a number outside parentheses, but it's still to a sum inside the parentheses. It's just that it looks like a difference. We have plus and negative. So we're going to have to keep that negative sign into account when we do our distributing. So we'll multiply with the first problem, for example, the number on the outside to every term on the inside of the parentheses. We're multiplying them together. So that will give us 2 times x, and then plus, we would have 2 times negative 1. So that would simplify to 2x plus negative 2, which is just 2x minus 2. Then for the second problem, we would have 4 times x. So 4 times x is our first product, plus then we would have 4 times negative 8. So that would be 4x plus negative 32, which simplifies to just 4x minus 32. So we can then check our work and confirm that 2 times the quantity of x minus 1 does equal 2x minus 2, and 4 times the quantity of x minus 8 does equal 4x minus 32. These expressions are equivalent. So we can generalize with the distributive property where the location of the number is on the outside of the parentheses, and also if there is a plus or minus inside the parentheses if we're distributing to a sum or a difference. But it's the same idea. We're always taking the number on the outside, whether it's in front of the parentheses or after the parentheses, and we're multiplying it to everything inside the parentheses, whether it's a sum or difference. So the most common form you'll see is the first, where you have a times the quantity of b plus c equals ab plus ac, where we have this example that 2 times x plus 3 is 2 times x plus 2 times 3, which is 2x plus 6. That's the most common way you'll see your expressions with the distributive property, but the rest of these formats could follow as well. You could have your number not to the left of the parentheses, but to the right. So that would be the quantity of b plus c times a still equals b times a plus c times a. So we have this example here where we have the quantity of x plus 7 times 3. We're still distributing that 3 even though it's on the right side of the parentheses. We're going to do 3 times x plus 3 times 7, which is 3x plus 21. And then we can see with the next two formats that we can also have the distributive property with subtraction. If we have a times the quantity of b minus c, we can think of that as a times b minus a times c. We don't even have to do a middle step of plus and minus where we're adding a negative. We can go straight to that subtraction. So for example, 5 times the quantity of x minus 2, we'll do 5 times x, and 5 times negative 2, so that gives us 5x minus 10. And then lastly, we could also have subtraction and the number on the right side of the parentheses, where we have the quantity of b minus c times a is equal to ba minus ca. So our example is we have the quantity of x minus 3 times 6. So we're still distributing that 6 to everything on the inside. So 6 times x and 6 times negative 3 gives us 6x minus 18. The distributive property can also be used to eliminate parentheses in problems, and so then you can combine like terms. As you've seen, once you distribute, the parentheses go away. For example, in this problem, we have 3 times the quantity of 4x minus 6. So we would distribute the 3 to 4x, so 3 times 4x, and then 3 to negative 6, so that would be, or 3 to 6 where we're subtracting them, so that would be 3 times 6, so 12x minus 18. Now here with this problem, 12x and negative 18 are not like terms, so that's where we stop. We don't go any further, but if we could combine the like terms, now we can, or now we would have the opportunity because the parentheses are gone. Let's look at one more example. Here we have negative 2 times the quantity of x plus 3. So again, using the distributive property, we're getting rid of the parentheses around the x plus 3, or we're getting rid of the parentheses in the expression completely. We would multiply negative 2 times x plus negative 2 times 3, which gives us negative 2x plus negative 6, or just negative 2x minus 6. And again, these are not like terms, so we wouldn't go any further, but it would give us the opportunity to if we had like terms because we no longer have parentheses. So using the distributive property, we keep that in mind, and it helps us simplify expressions as far as we possibly can. Let's actually take a look at one more example where we have a lot of negative signs, just to make sure we go through the distributive property and we don't get confused when we're multiplying our negatives and adding our negatives and our minus signs. So for example, we have negative 3 times the quantity of 4x minus 6. So the number we're multiplying on the outside is negative, and we're multiplying to a difference. So that would give us negative 3 times 4x, which is negative 12x, and that stays the same. Then we would have negative 3 times negative 6. So we can think of that as we're subtracting. The subtracting sign stays the same, but now we have negative 3 times 6. So that's now minus negative 18, which is really plus 18. So just watch your signs when you're distributing as well. It's important to make sure if you're distributing a negative sign to a sum or a difference that you really follow your sign rules to make sure your expressions stay equal when you use the distributive property.